Hi, I'm Amanda Metters-Paldau, and I'm the owner of Triad Tutoring. And today we are going to take a look at the official SAT study guide, test number 2, section 4, number 30. And this is a problem that will show up mostly infrequently on the test. This would be additional topics in math, which is only represented by about 10% of the test. But it is important to remember some of your geometry rules for these types of questions. So here we have a regular hexagon, and keep in mind that regular means all of the sides are equal and all of the angles are equal. That's what makes something regular. The sides of length A, and then the square is connected to it. So the area of the hexagon is 384 times square root 3 square inches. If we want to talk about the area of the square, a couple things we're going to talk about. One is doing it the mathematical way. So looking at this, we have we can break our hexagon into triangles. So if I break this into triangles, I can see that I have 6 equilateral triangles. So if I take my area, 384 root 3, and I divide by 6, I can find out the area of just one of those triangles. Right, so 6 goes into 38, 6 times, 2 left over, so I'm left with 64 root 3. So that's the area of one triangle. And the reason I'm doing that is because I want to find out what the base of the triangle is, so that way I know what this length of the square is. So I know that area of a triangle is 1/2 base times height. And I also know that this is an equilateral triangle, which means if I think about what the height of an equilateral triangle is, I know that once I drop that height down, I've created a little 30, 60, 90 triangle there. And in a 30, 60, 90 triangle, I know that 1/2 base would be sorry, the pen has gone a little crazy. Okay. In a 30, 60, 90 triangle, I know that this side is x, this side is x root 3, and this side is 2x. And if I wasn't sure about that, I could check the front of my book where they give us the formulas, because this is one of the ones that's given to you. So that x value is 1/2 of the base, right? Because it's half of that equilateral triangle. So I can sub in x for 1/2 base. And then the height we said is x root 3. So for height, I'm going to put in x root 3. And I end up with, and I still have it equal to 64 root 3. So now if I solve this, I get x squared times root 3 equals 64 root 3. I can divide by square root of 3 to get the x squared by itself. And now I'm left with x squared equals 64. So my x value, take the square root of that, is 8. And be very careful of what 8 is. 8 was half of the base, not the whole base, which means my whole base is 16. So I know that it's 16, and I know that the area of a square, which is what they're looking for, is side squared. So 16 times 16, which is 256. Now, let's say I didn't remember any of that math, and I was doing this problem. Another thing you can think about, this is the calculator section. So I could have plugged into my calculator 384 times square root of 3, and I could have figured out what does that equal. So what is the area of that whole hexagon? And the reason I'm saying that is because the images are drawn to scale. So I know that the total area is about 665. And I can see how big is the square compared to the hexagon. I know it's not a whole half, but it's fairly close, right? I could see, maybe the square fitting in this amount of space, somewhere along those lines. So it's probably somewhere around a third of the area, right, of the hexagon, if I was just kind of eyeballing it. So if I think about what 665 is divided by 3, that gave me 221. So even if I was just looking at the picture and just thinking about how much is it compared to the total, I would get pretty close, and I would be between A and B, and very likely to pick A. I would certainly know that it wasn't C or D. So again, even if you feel like your geometry is a little bit shaky and maybe some of the other work you wouldn't have remembered that process, you can still at least use process of elimination and use your diagram to help you. Hope that helps, and thanks for watching.